I hope I'm audible. If I am, please. I hope I'm audible, guys. If I am, please mark a yes on the chat pod. Let's check the audio first. All right, that's great. Cool. So, welcome everyone. Good morning, good evening, and from wherever you're joining us, thanks for joining us in this session of even and odd number properties. Now, in this session, we are going to discuss something really important, and that would also help you to get to that target score of yours that you want to achieve. Now, in this session, primarily it's focused on even and odd properties in number system, but the learnings that we would be taking from this session can be applied to the entire GMAT Quant, or I would rather say entire of GMAT, and that would help you out to go to that score that you essentially want to go to. Now, with that, let's understand what are the goals for this session. Now, in this session, I would try to help you out, and I will also show you one unified approach to solve 700 plus level GMAT context questions with 100% accuracy. Not in 2 hours, but we'll do that in an hour and a half at max, right? So we'll do that, and everything in this webinar, would be done within using a single unified approach. Now, the best thing about this webinar is now we'll be discussing a lot of questions. I'll get to that point, but the approach that we would be using, it's very easy to learn, and once you inculcate that approach within your habits, solving every question in GMAT even or property becomes a real cakewalk for all of you. Now, I have three screens here, so I'll be looking at each of them, and at times you might not see my face regularly, but so this is my surface. I'll write it out here, so I'll still stay connected. Okay, so with that, let's move on to the flow of the session. Now, in this session, we'll be first of all doing some warm-up questions, and we'll be getting four warm-up questions as of now, right? So we'll be doing four warm-up questions, and post that we'll discuss the solutions to those questions, and then we'll do some concept revision as well. The concept revision that we're talking about here is basically revising the entire concept of even not in about 5 minutes, and I'll also help you to get to that unified approach through that. After we discuss the concepts, we'll move to our first sprint. Now, in the first sprint that we have, we'll be solving three questions. And these three questions are typically of the range of 600, 650. And then we'll discuss the answers for those questions and then move on to our sprint two. The sprint two that we would encounter would be having three questions, but these three questions would be the most difficult and challenging questions of this session, and these questions are of the 700 720 level, right? And after we are done with sprint 2, we'll go to the feedback session, and then we'll also note down the key takeaways that we learned through the session. Now, throughout the session, I'll also help you to understand what are the points where people essentially falter, and so that you people have an idea and you do not make the same mistakes again. Right, so are you ready for the warm-up section? So let me give you the instructions first. Now, you would be getting four questions in the next slides, and also would be sharing a form link with all of you. What you need to do is you do not have to check the slides. You go to the form link, click on the form link, and in the form link, you get the questions as well as the answers. Now, what you do is put down the answers in the form itself, right? Please refrain from posting your answers in the chat box, as it really does not suit other people. And you can see the form link is up. So we'll have four questions and 4 minutes to answer this. And all the best to all of you. Let's join back in the session after you attempted the four questions and put your answers in the form that has been shared with you in the chat. All right, another 30 seconds to put down your answers. You have the form. Please put your answers in the form. I already see a lot of responses. Let's get some more responses, please. Okay, see, someone has completed and got 100% score. That's really good. So we expect you people to get 100% score in the warm-up section because in these questions, we're not that difficult, correct? All right, with that, let's move ahead and discuss the four questions. Now, this was the first question, fairly easy and based on a property of even odd. The second question is fairly easy and we'll take a very important feedback from this question and we'll apply that in the next questions as well. This is a slight differentiation from the previous question with an added difficulty, I would say. And this is the fourth warm-up question where we had a DS question, and it's also not that difficult. So let's now check out the solution for these questions. Now, in the first question, I'm going to take some time because it's really important for all of you to understand uh, the rest of the session. So let's take some time to understand this question. The question asks me, if the product of two integers p and q is even, which of the following statements must be true? So I'm looking for a statement that is definitely true. Now it's given that p times q is an even number. So what are the different possibilities that p and q can take? The different possibilities are p can either be odd or even, and similarly q can be odd or even. So we have a total of four possibilities as shown in the figure right here. And in accordance to that, we have calculated the product of p and q, where okay, we have calculated the product of p and q, where we see that for some cases it's odd, for some cases it's even. Now, with that, let's move ahead with the solution for this question. Now, in this question, we can see that in all the three cases where the product is even, at least one of the values of P or Q is even, right? So here in the first case, I see Q is even. In the second case, I see P is even. And in the third case, I see both P and Q are even. So that essentially means that for any product of two numbers to be an even value, at least one of them should be even. So for that, the answer for this question is option A. Okay, I see that Shotrabhuta has a comment that last one got wrong because you mentioned 30 seconds. Oh, never panic. It's all fine. Even if 30 seconds is left, just take your time, put down the answers, and that should be fine with you. Now, with that, I hope this solution is clear to you. And with that, let's move on to the next question. And the next question is also very similar in nature. If n is an integer, then what is the even odd nature of n plus 5 times n plus 6? Now, if n is an integer, there can be two possibilities. First, n is an even number, or second, n is an odd number. Right? So there are two possibilities. Now, if n is even, n plus 5 is odd and n plus 6 is even. So what you can see, if I do a product here, I'll get an even value. When n is odd, the value of n plus 5 would be even and the value of n plus 6 would be odd. Now, even if you multiply these two, we get the product to be even. So in both the cases, we end up getting the product to be even. So the answer for this question is option A, but there's one simple thing we also need to understand from this question. Now, you see that the two terms here is n plus 5 and n plus 6, which are essentially two consecutive terms in the number system, right? So if I, let's say, assume that n is equal to 1, the value of n plus 5 would be equal to 6, and the value of n plus 6 would be equal to 7. Let's take another example. Let's assume that n is equal to 10. For that, n plus 5 is 15 and n plus 6 is 16. So you can see these two numbers are consecutive numbers. Now, if we have two consecutive numbers, one of them has to be even, right? Because we have alternate even numbers in the number system. So that is the reason we put up this question for you, to understand, to make you understand that whenever you see this kind of an, you know, question where we have this kind of a phrase, let's take this as a feedback from the question, that we need to always consider this to be consecutive numbers, and will bring the properties of consecutive numbers to us, and to, you know, essentially see what the question has to offer. Right, with that, we'll move on to the next question. The next question is a simple, very simple, an extension of the previous question. The question asks me, if n is an integer, then what is the even odd nature of 4n plus 3 minus n plus 5 times n plus 6? Now, the moment I see that I have this kind of an expression, I would say that these are two consecutive numbers. In two consecutive numbers, I have a even number, right? And when an even number is multiplied with another number, the product is always even. So I can write that it's always even. Now, so since this is even, there would be two cases. 4n plus 3 can either be odd or even. Now, when I add or subtract an even number from an odd number, I get the result to be an odd number. When I add or subtract an even number from an even number, I get the result to be an even number. So if I'm adding an even number, you know, to any number, the valuation of this is essentially zero. It doesn't add anything to the expression. So what I can essentially do is cancel of the part that is giving me an even, the cancel of the even part. So basically what we can do is, we have 4n plus 3. We'll just calculate for 4n plus 3, because we already know that the other part is even, right? So I have two possibilities. 4n plus 3 can either be odd or be even. Now, 4n, this is always even, correct? This is always even because we have an even number attached to n. So this part is always even. We only have 3. So 4n plus 3 cannot be even or odd. It will always be an odd number. Now, if this is an odd number and then I subtract an even number from this, the result would be odd. And that brings us to this question, the answer to this question, that is option B. And I hope this is clear to all of you. The level of difficulty for this question would be somewhere around 500, 550. Yes, these are warm-up questions. All right, let's now move into the next question, which is x, y, z, and w are positive integer. I need to say whether x is odd or not. Now, the question doesn't give me much of an information. It just gives me one constraint, that all of these number variables, x, y, z, and w, these are positive integers. That means they're greater than 0, or essentially I can write they're greater than equal to 1, right? And they're positive integers. Now, if I go to statement one's analysis, what do I have? I have 7x plus 8y plus 4z plus 5w, and this is given as odd. Now, as in the last question we did, we'll apply the same thing here as well. We see that these two numbers have an even coefficient, and we know that if I have an even coefficient, then the entire number is always even. Even if I add or subtract, it does not essentially change the even odd nature of the entire expression. So I'll just cancel these out from my expression. What do I have now? I have 7x plus 5w to be an odd number. Right now, the sum of two different expressions is odd. This brings us to another conclusion, that either this is odd and this is even, or 5w is odd and 7x is even. So these are the two possible cases that we can draw from this. Now, if 7x is odd, then x has to be odd. But if 7x is even, then x also has to be even. So from the first statement, we get two different answers. We cannot get to a simple answer. So for this, statement one alone cannot essentially solve this question. Now let's move to the second statement's analysis. In the second statement, we have an expression which tells me 3x plus 2y plus 8z plus 2w is even. And as we have already discussed, The moment we see even coefficients, they're not going to affect the expression, so you can simply cancel them off because that would not end up affecting the entire expression that I have. So I can essentially say that here 3x is even. Now if 3x needs to be even and I see that 3 is an odd number, x definitely has to be an even number. So here we can answer the question whether x is odd or not. We can say that no, x is not odd from the second statement's analysis. So this would give us to the answer, and we can say that the second statement is the correct statement. The answer for this question hence becomes option B. Now, all these four questions that we did right here would be of the easy level. This is just to give you an idea of the next questions that we would be getting. Now, all these four questions also had some learning in each of them. So we'll now look at all the learnings through a revision of the concepts that we have in even and odd. Right? First of all, there are two things that you need to remember throughout the entire journey when you read number properties. That is, sorry, all right. That is, for every even number, they can be represented in the form of 2n, where n is an integer. And for every odd number, they can be represented in the form of 2n plus 1, where n is an integer. These are the basic representations of an even and an odd number. Now, this might not be that important, but the most important things that you should keep in mind to ensure that you are good at even odd properties are these basic properties, and then we'll derive some properties out of them as well. As we discussed in the questions, when I add or subtract an even number, it essentially does not affect my entire expression. So whatever my previous number would be, it would be same. So here I can say that when I add or subtract an even number from even, the parity remains same. It's an even number. When I add or subtract an even number from odd, again the parity remains same. It's an odd number, right? The even part does not change anything. But when I add or subtract two odd numbers between themselves, then I get an even number. So this is a very important point. Then when I multiply an even number with an even number, I get an even number. When I multiply an even number with an odd number, I get an even number. So if you club these two, if an even number is multiplied to an even or odd, it can be any number, then the result is always an even number. And that was the reason why we were continuously, removing those terms which had even coefficients. So these are the small things that you always need to keep in your mind to reduce the length of questions, to simplify calculations at your end. And lastly, when I multiply two odd numbers together, the product that I get is also an odd number. Now, from these, we get some derived properties as well. Now, let's take any even number into consideration. If you raise that to the power n, then the even odd property of the same number, of the number remains same. Let's take an example. Let's consider the case of 5 square and 5 cube. Now 5 square returns me a value of 25 and 5 cube returns me a value of 125. Despite the exponents being even and odd, the result that I have here is always odd. So the exponents won't affect your number. The base is what you need to consider to get to the final answer. Let's take another example. Let's take the example of 4 square and 4 cube. Now 4 square returns a value of 16 while 4 cube returns a value of 64. You can see that even if the exponents are odd and even in their nature, essentially the value that they returned is even because the base number is even. So this is a very important takeaway from the section of even and odd, which is exponents do not affect the even odd nature of the base number. The essentially the if it's even or if it's odd, the number remains same. It won't change. First, there are a few exceptions though. We'll talk about that, and then the next thing is if you multiply an even number with any of even or odd, the product is always an even number. And lastly, even numbers, when I have them in my expressions, they do not affect my expression, so I can easily not consider them and move ahead with the next part of the expression. Now, as I've written here, there are a few exceptions. For example, let's take the example of 4 to the power 0. Now, despite the number being even, the base number being even, and the exponent being given as well, I get the value of 1, which is odd. So this is a very important exception that you have to keep in mind, and this is also something that GMAT tests us a lot. So whenever the power of a integer is equal to 0, then the value that we get is equal to 1. This does not qualify for 0 to the power 0, but yeah, for any other integers, the integer to the power 0 would always return me a value of 1. A very important takeaway that would be used in the questions that we solve next. Now, with that, I hope the revision of concepts at your end is done, and I hope you would now use these techniques and these takeaways to solve the next set of questions that I'm going to give you. But before that, if you want to go more deep dive into in number properties, then what you need to do is click on this access link where Shweta, who is supporting me today, she'll help you with the link. The link just popped up in the chat box, so you can click on this link and go to the number properties free trial to witness it. It's almost it's not almost, but it's better than a private tutoring pedagogy that you would be seeing in number properties module. You can take diagnostic quizzes, you can learn new concepts through interactive videos, you can practice quizzes, and the best part out of out of the entire process is the entire process is very progressive. So you start from 0, you then reach to 100 with a continuous feedback at your place. So the system would give you a continuous feedback. To get to that, you can just click on the link below and register and in the platform. With that, let's now move on to Sprint 1. Now, Sprint 1 has some good questions. Now, these are questions typically in the level of 600 to 650, 700, and these are good questions. So again, the instructions remain same for you. The link has been posted in the chat box. What you do is go to that link, open that link. You would get 6 minutes to solve out these questions. You can answer in the link itself. You don't have to post your answers in the comment box. That essentially breaks the overall flow of the session. So please open the link that has been shared. You get the questions there as well, and mark your answers in the same link. All the best. All right, just 20 seconds more. 20 seconds more, guys. Let's put down the answers in the poll. And until that, also let me know how were these questions. Not that difficult, right? So we're just going in the session progressively. So we first solve some easy questions. These are some medium questions, and then we'll be targeting some difficult questions to understand that our learning from zero happened to 100 or not. So as we can see here, and you can see here as well, that the answers for the first questions are here, and I see a lot of people selecting option A. Yes, option A is absolutely correct. So let's go question by question. These were the three questions. Let's start discussing their solutions. So this is the first question that that I had at hand, right? If it's given in the question that if A plus B is even, all right, what is the remainder when A to the power 7 minus B to the power 5 is divided by 2? Now, to understand this question, a very important thing, or rather, a translation is required, right? We require a translation for this question, and what is that? Now, what we need to think is, what is the relationship between a number being even or odd and the remainder when I divide that number by 2? Now, for any even number, we already told you, right, that it is of the form of 2n. Now, when you divide a number which is in the form of 2n by 2, the remainder is always 0. So, even numbers, when divided by 2, always give me a remainder of 0. And odd numbers, which are in the form of 2n plus 1, when you divide them by 2, give us a remainder of 1. So here we need to answer whether the answer whether 0 is correct or 1 is correct, or I cannot determine the answer. So that was the first step. The second step is to simplify what the question statement is saying, right? It's given when a to the power 7 minus b to the power 7. And in the last slides, we already discussed powers do not affect the even odd nature of the number. So a to the power 7 minus b to the power 7 is simply a minus b. That's it, right? Now, it's given that a plus b is even. So if a plus b is even, there are two possibilities, right? If this is even, there are two possibilities. A is even and b is even, or a is odd, b is also odd. So when I calculate the difference between these two numbers, the difference of two even numbers would always be an even number, and the difference of two odd numbers would also be an would also be an even number, right? So here a minus b would be equal to even. So now, when you see this, that we have even in both the situation, we can go to the point here that we've written that even numbers when divided by 2 give me a remainder of 0, and just mark option A as the right answer. Very easy, right? Let's move on to the second question's solution. And in the second question, it's given that a and b are two positive integers, so that a squared by b gives an even quotient. We need to understand what is the remainder when a to the power b minus b to the power a is divided by 2. Yes, understandable. But again, Nikos, what you need to understand is that that is not tested in GMAT. So what you get in GMAT would be integral itself. Again, if that were the case, we would have had more cases to consider, and maybe then the answer that we would be selecting would be cannot be determined. I hope that resolves your query, but we always have to look at the constraints given in the question, right? All right, so here the constraints given in this question is a and b are positive integers. So how do we solve this out? Again, we need to find out the remainder. We know that even numbers when divided by 2 give me a remainder of 0. Odd numbers when divided by 2 give me a remainder 1. So I need to understand whether a to the power b minus b to the power a is even or of the nature odd, right? So with that, now a to the power b, a square by b is given to be an even number. This is what's given in the question, right? Let me just, okay, just give me one moment, please. All right. So this is given as even. There's some issue here. So a square by b is given as even. We need to find out where a is even and odd or b is even and odd, and then move on to solving the question. Now, if a square by b is even, then what we can write, and let me delete this part so that it becomes more easy for you to read. So what I do is I multiply b to both the sides of this equation to get to the value of a square. So I can write a square is an even number times b. Now, even number times b would always be an even number, right? So a square would be an even number. And we have already told you if a square is an even number, then a is also an even number. So A is an even number, but do we have any information on B? We do not have any information on B. So the value of A to the power B minus B to the power A, determining this value, the parity of this, whether this is even or odd, becomes really difficult for us since we do not have any information on B. And since we cannot do that, we cannot say that the value is even or odd, and then go to answering whether the remainder would be 0 or 1. That is the reason we would be marking option C in this question. And I hope with this it gets your doubts gets clear, because I see a lot of people also choosing the first option, that is almost 41% of you have chose option A, that is this is an even number. But again, if we do not have B, we cannot determine the same. With that, let's move on to the third question's solution. Now here it's given that x to the power 3y minus 1 is even. Then we need to understand what is x, even or odd, where x and y are integers. Now let's look at the question stats, the answer stats for this. I see 9% of you choosing option A, 60% of you choosing option B, and 31% of you choosing option C. All right. So here, let's discuss the question in detail because a lot of you chose the wrong options. So here it's given in the question that x to the power 3y minus 1 is an even number, right? So when I take 1 to the right hand side of this equation, what do I get? I get x to the power 3y to be even plus 1. And what is even plus 1? It's simply an odd number, right? So x to the power 3y becomes an odd number. Now it's given in the question that x and y are integers, but they can be negative integers, they can be 0, they can be positive integers. So this is the constraint that we need to understand and we need to keep in our head to get to the answer. And I guess a lot of you who marked options A and B made a mistake in the same property. Now, if the value of y is equal to 0, right, then what do I have? I have x to the power 0 to be an odd, and I know any number to the power 0 would always return me 1, and 1 is odd. So x can be even, it can be odd as well. But since y is equal to 0, the value of x to the power 3y becomes odd. So from this part, we cannot determine whether x is even or odd. We can try out with other as well. We can try out with y greater than equal to 0 as well. But since we already have this, that x can be even or odd for one value of y, we cannot go and mark the answer. So this was the trick in this question. And again, let's take this as a takeaway from this question. Let's take this as a feedback that's given to us from this question, that we need to consider all the cases that are present in the scenario. So for that, what's important is you look at the constraints that's given in the question. That's really important for you. And I hope with this solution, from the next question onwards, you would not be making the same mistakes. Right, all right. Let's now understand the takeaways because that's very important for you. So, understand like the first four questions and the next three questions, we have solved seven questions already, but all of these questions were solved using one unified approach. I just saw whether the number is even or odd, calculated the next parts, and then went on solving the question, right? So we do not assume numbers first. Now, a very important thing here is a lot of students assume numbers in number properties and also in even properties, but they end up faltering in points where GMAT essentially tests us. Now, GMAT knows that students would be faltering in these points if they take random numbers, to solve a question. So we are well aware of that. We'll keep ourselves well aware of that. will not use numbers, will go by the normal approach, will go by the proper approach and solve the question. The second thing, a very important key takeaway that would help us lower the level of difficulty or the complex, the complexation of the entire problem is, if you remember that power does not change the even odd nature of the expression. This would reduce the complexity of the entire question by a lot. When you start realizing that if I have powers, I just need to let them go. Again, two very important things. If we have even numbers, then the remainder is always zero when I divide them by two. If we have odd numbers, when I divide them by two, I get a remainder of one. Now, with these takeaways, and we also learned another takeaway that y can be equal to zero. So we always need to see whether this case is possible or not, because that's one very important filtering point, and GMAT loves testing us on that. Right, so with that, let's move ahead with the next part. But before that, if you, again, I've told you this before as well, if you need access to if you want to witness a private tutoring like teaching pedagogy, I would say that go click on this link that just popped up in the chat box. You would get access to diagnostic quizzes. You can learn concepts through interactive videos. You can practice quizzes, and you can also see application quizzes where we hold your hand to essentially show you that these are the ways in which you solve a question. And so that is only available till Sunday. That is November 29th. This would be Sunday, November 29th. And I hope you would really love that content out there. So just click on the link that popped up, and that would be it. We also have a GMAT Algebra webinar tomorrow, and in that webinar, I am going to discuss very good questions on inequalities and absolute values, and we are going to master that entire topic in literally 2 hours. So I'll just request Shweta to essentially put out that link in the chat box so that you can also register for that webinar. Yeah, the link just popped out. Yes, all these are for free, Satya brother. All these that I'm talking about are for free. You just need to go and just click on the link, and you can see it yourselves, right? And the next thing is, and this I love this part. This is where you can book a one-on-one call with one of our certified strategy experts and get all of your doubts cleared with respect to GMAT preparation. Now, we have a wonderful team here who will help you out with your GMAT strategy and with all the resources that you need to go to that target score that you're aiming. Keep in mind that this is a first come first serve basis. So just click on that link that popped up right in the chat, and you can book a call right away. So we'll just wait for another 5 seconds and then move ahead with the next part. All right, and the next part is the part that I really love. In this part, that is sprint 2, we would be solving three very good questions on data sufficiency on number properties, even odd. So Shweta is just going to give you that link in the chat pod. The link just popped up. What you need to do is click on that link. You would get to those questions where we have three questions. All of the questions are 700 plus level questions. You have 8 minutes to solve all the three questions. And then let's discuss these questions once you are done. All the best, guys. All right, we're just gonna take one more minute and then let's discuss the answers to these three questions. All right, five, four, three, two, and one. So let's now start with these questions. So first of all, while Shweta also gives us the results for these questions, tell me how were these questions, guys? Were they challenging? Were they medium? Were they easy? Let's first get the feedback from you people. How do you like the questions to be? And the answer statistics are distributed. So we'll get to that as well. While Shweta gives us the responses. But yeah, tell me, did you like these questions? How were these questions? Lots of cases, right? Yes, these are medium to hard questions, and essentially these are 700 level plus questions. So that is so again what we have learned before in the last seven questions. We'll just try to apply the same concepts and try to solve these three questions as well. Will not take a lot of time. Do not worry. Now, if you felt that you are taking a lot of time after we discuss the solutions, hope I hope you people get to that point where you can really lessen your calculations by those small tips and tricks that we were talking about throughout the session. Okay, every time you had second thoughts, that's really good for us because that's we actually want to make questions that challenging. That so when you get these questions correct, that will build that confidence inside you, right? All right, let's now move to the first three questions. Let's discuss the answer for the first question. The question asks me if P and Q are non-negative integers and P is greater than 0, then is Q divisible by 2? Now, is Q divisible by 2 can also be answered whether Q is even or odd. If it's even, yes, it is divisible by 2. If it's odd, no, it's not divisible by 2. So we need to understand what are the different possibilities, right? So the first statement that I have is P plus Q times Q minus P is even. Now, before I move into the first statement, let's just first gather all the information that the question is presenting to me. So the first thing that the question asks gives me that P and Q are integers, they're non-negative integers. So P is greater than 0, it's given, and since Q is non-negative, you can have two possibilities. Again, we're breaking the question into two parts because there is that possibility of Q being equal to 0 that hampers my entire calculation, right? So keep Q to be equal to 0 to be one possibility and Q to be positive to be the second possibility. Now, let's go to the first analysis of the first statement. In the first statement, it's given that P plus Q times Q minus P is even. So this can be treated as A plus P times A minus P, and we know that gives us A square minus P square. So I've written that same. So Q square minus P square is even. And we have already known that power does not change the even odd property. So one step down. So what we can write is Q minus P is even. Now if Q minus P is even, it's again working up a bit. So let me clear this. And yes, so there are two possible cases. The first case is both of them is even, both of them are even. The second case is both of them are odd. Only then the difference would be even, right? Now post that, let's go to the analysis of the second statement. In the second statement, it's given that p to the power q plus q to the power p is odd. And we have two cases. The first thing is q is equal to 0. The second is q is greater than 0. So let's divide this entire part into two places where q is equal to 0 is 1, q is greater than 0 is 1. Now, when q is equal to 0, then I just substitute the value of q in this statement that I have here. So what I get is p to the power 0 plus 0 to the power p is odd. Now, p to the power 0 and p I know is greater than 0 and integral. So that would give me return a value of 1, and 0 to the power p, 0 to the power anything is essentially 0. So that's equal to 0. So 1 plus 0 is an odd number. So this is true for q to be equal to 0, and q being 0 essentially means that q is an even number. But we had no idea on p. Since we had the power to be equal to 0, q can be the value came out to be 1, but we do not know whether p is an even number or an odd number. So this is something we would be keeping in our head. Let's now discuss the second part when q is greater than 0. When q is greater than 0, and it's given that p to the power q plus q to the power p is odd, will again apply the same concept that powers does not change even odd nature and simply write that p plus q is odd. That leads us to two different cases. Either p is even, q is odd, or p is odd, q is even. So two different cases from the second statement's analysis, from the second part of the second statement's analysis, and two different cases from the first part, and uh, you know cases from the first statement's analysis as well. Now, none of these gave me a proper information on the values of p and q. There was always more than two or two possibilities. So neither statement 1 alone is sufficient, nor statement 2 alone is sufficient. So what we do in this case is we combine the information that we got from both these statements. Now, if we combine both the statements together from statement 1, I get that P can be even, Q can be even, P can be odd, Q can be odd. And from statement 2, there are two pieces of information that Q can be equal, Q is even, Q is equal to 0, but I do not know P. And the second case led us to the possibility that P is even, Q is odd, and Q is odd, P is odd, Q is even. Now, from this part, what we can get is, since Q is odd and we do not know the values of P, there are two possibilities for P. P can either be even or be odd. Now, keep in mind that Q is even in both the cases because Q is equal to 0. Now what we will try to guess is what we will try to get is, is there any common possibility from statement 1 or statement 2? And I see yes, there is. If you look at the first possibility from statement 1 and the first possibility from the first case in statement 2, both of them are same. So when I combine the information from both these statements, yes, I can reach to the final answer, which leads me to the correct answer being C. And if I look at the question statistics, only 36% of you got this question correct. A lot of you marked option A and option E, almost 20, almost half of, almost one fourth of the entire class. So this is something we have to keep in mind. Now, the calculations might be a bit tricky, not tricky, but I would say lengthy. It would take us a bit of time, but that's what difficult questions in GMAT are, right? So what we would have to keep in mind is never ever try to put in random numbers. They would always lead us to those pitfalls that are already set for them. So we would just be following the normal approaches to get to the final answer of ours. Right? With that, let's move on to the second question solution. Now, this is also a very interesting question and my personal favorite. In this question, let's first look at the question statistics. So, how many of you? So, 45% of you marked option A. All right. Then I have option C being marked for by 36% of the students, and option D marked by 19% of the students. Yes, the answer for this question is option A. So everyone who got that correct, well done. Now let's go into this question and try to solve this question in the shortest amount of time possible. What is the question asking me? Is the expression, I have a very big expression. So this should, get this, I should get this in my mind the moment I see these kind of complex expressions, that there is a better way to solve this out. GMAT is just trying to trick me. I will not get tricked. Where A, B, C, D are non-negative integers, and we also have been given a relationship between A, B, C, D, where D is the largest, A is the smallest. And then we have two statements. So we have a lot of information in the question stem. The first thing that we need to do is reduce the complexity of the question stem. So let's look at the solution. We need to find if 5b to the power 7 c to the power 4 minus 10 a to the power 3 d to the power 5 is odd or not. Now, I told you guys already this, that whenever I have an even number, now 10 is an even number, right? So the entire part becomes even. When I add or subtract an even number from an expression, does not affect anything. So I can simply get rid of that. So what do I have? The question is just asking me whether 5 b to the power 7 c to the power 4 is odd or not. So another thing to note is, before that step we can also use the step of that powers do not affect the even odd nature, and that is the reason why we have written it here. We have just converted b to the power 7 c to the power 4 into b times c, a to the power 3, d to the power 5 in terms of a and d. So again, this is even. So what I do is I write 5b into c minus an even number is an odd number or not. I need to check that. So the question is asking me whether 5b times c is odd plus even, or essentially whether 5b times c is odd or not. Now, when is 5b times c odd? It means that when b times c is odd or not, or essentially when is b times c odd? When both of b and c odd. So the question is asking me whether both b and c are odd or not. Now, this entire process, it would take you around a minute to think, I'm sure, for the first time. But from this complex an expression to just answering whether B and C are odd, this would reduce a lot of time when I move back to analyzing the statements that I have in the question. So this translation of the entire question into parts and then getting to that last bit is really very important to crack those difficult GMAT questions at hand. Right, so with this, we have one simple information that we need to check whether B and C are odd or not. So let's go and analyze the first statement. The first statement tells us that A, B, C, and D are consecutive integers. Now, this leads us to two possible cases. A can be even, A can be odd, and depending upon that, we have an alternate even odd nature. Similarly, if A is odd, B would be even, C would be odd, D would be even. If you look closely for the cases of B and C, you would see one of them is even, the other is always odd, right? So one of them is even, the other is odd. So are both B and C odd? Can we answer this question? Yes, we can answer this question that no, both B and C are not odd. Since we can answer this question, we would say that this statement is sufficient for us to mark the answer for this question. So now what are the possible answers? I can choose option A, I can choose option C, right? These are the two possible answers that are, sorry, I can choose option D. These are the two possible answers that I can choose. So let's go to the analysis of the second statement. In the second statement, it's been given that 5c to the power 4a is odd. So there are two possible cases. Again, we'll try to divide it into two possible cases where we take that value of a, because I've already told you, a disrupts the entire functionality. It disrupts the entire calculation piece. So taken that into two pieces, a is equal to 0, a is greater than 0. So what are the two different cases? A is equal to 0, a is greater than 0. When a is equal to 0, the value of 4a becomes 0. So what do I have? I have 5c to the power 0, and that always is equal to 1, right? So c to the power 0, it would be 1. So this would be 1 times 5, and 1 times 5 is 5, which is an odd number. So when a is equal to 0, this is odd. So c can be odd or even as well. Now, why would we say this, that c can be odd or even? Now, c to the power 0 gives us the value of 1. It would be same for 2 to the power 0 or 3 to the power 0. We do not know c is 2 or 3 or any other even or odd number. We just get that c to the power 0 is equal to 1. So it cannot determine the value of c, the nature of c, whether it's odd or even from the first part. Let's now look at the second part. If a is greater than 0, if a is greater than 0, it's given in the question, the statement that 5c to the power 4a is an odd number. So again, we'll use the same approach that we used in the last question, that power does not change the even odd property, right? So we can simply get rid of 4a, and we can say that it's given in the question that the value of 5c is odd. Now, if 5c is odd, then definitely c would be an odd number as well. Now, if c is an odd number, we can tell about the nature of c, but can we answer about the nature of b? In the entire statement, there is no mention of b, right? So from this case, I know the value of c, but I cannot comment on the value of b. So since there is no information of b, this statement, the second statement, is not sufficient to answer this question. Now, if this is not sufficient, then the answer for this question is option A because D goes out of the chart, right? So the answer for this question is option A. With that, let's move ahead to the next question, question number 3. Now, this again is a very good question. Let's look at the statistics. So 50% of you marked option A. Let me write it down here. 50% of you marked option A. I have 36% people who tell me that the answer for this is option C. A fair share of people telling it's E because I see 11% over here. All right. So now let's move back to the question and try to answer this one. Now the question again seems very lengthy. We have powers, n's, a, b, c, d, so much constraints given in the question. Let's take one piece at a time. Let's segregate the question into parts, divide it, and then translate the question into something that's easy to understand, right? So let's start off with the solution. We need to find out whether a to the power n minus b to the power n plus c to the power n plus d to the power n is odd or not. And we know that powers do not affect my expression. So what I would do is remove the n from here and just write the simplest expression, that is whether a minus b plus c or d is odd or not. Now, so there are 5 possible cases for that. The possibilities are as shown below. So A can be even, B can be even, C and D both can be even. So all the phone numbers can be even. If all the phone numbers is even, the value of this would be an even number, right? When one of them is odd, the sum of them would be odd. When two of them are odd, the sum would be an even number. When three of them are odd, the sum would be an odd number. And when all the four of them are odd, I would get an even sum. Now I need to check whether this expression is odd or not, right? So I'll just take the two cases here. So let me sorry. Okay, let me go to this place. So there are two possible cases for this entire situation. The second case and the fourth case. Let me also rub these out here. I don't know why my surface is acting up today. All right, so I have two cases here. The second case where three of the numbers are even, one is odd, and when one number is even, three of them are odd. So two possible cases. I need to answer from this question whether one of them are odd or three of the four numbers are odd or not. So from this complex and an expression, or a language, we came to this very simple translation, that I just need to find out whether one of these four variables are odd or three of the four variables are odd or not. That would lead us to the question. So any statement that gives us this information is a sufficient statement to answer this question. So let's move ahead with solving this question. Let's first analyze analyze statement number one. In statement number one, it's been given that A, B, C, D are squares of consecutive natural numbers, right? Now, if A, B, C, D are squares of consecutive natural numbers, again, squares, powers, just get rid of them. We don't require that. So what we can do is squares of, we can remove this part. Just take this information as A, B, C, and D are consecutive natural numbers, because the squares would also give me the same even and odd property. Now, if A, B, C, D are consecutive natural numbers, then there are two possibilities. That out of the four numbers, two are always even, two are always odd, right? This is the only possibility that we have, because let's say if a is equal to n, let me write it down here, or let's take examples to understand it better. If a is equal to 1, then b would be equal to 2, c would be equal to 3, d would be equal to 4, right? So we get two even numbers, two odd numbers. You can do the same for a to be equal to 2, and you would see that two of them are even and two of them are odd. Now, using this information, can we answer the question that is one of these numbers even, is one of these numbers odd, or three of these numbers odd or not? Now we know that two are odd and two are even. We can answer this question, right? That yes, I know that no, one of them are not odd, three of them are not odd. Since I can answer this question, then I can easily say that the first statement is sufficient to get me to that answer of mine. So this is the entire translation piece in this question is so very important if you want to solve this question nicely. And I only see 50% of people answering option A, which is essentially the right answer for this question. So all these people who marked different answers might not have been able to translate this difficult looking problem into this a simpler problem, or rather a statement. Right now, let's analyze the second statement because there's a possibility of D being the answer as well. So the second statement tells me that a to the power 4 when divided by 200 has the quotient of 1. So in this statement, I only have A, where's B or C? I do not have any information on B or C, right? B can be even, odd, I don't know that. So since I do not have any information on B or C or even D, I cannot say that whether one of them or three of them are odd numbers or not. So from that, we say that the second statement is not sufficient to answer the question. Since the first statement is sufficient and the second is not, the final answer for this question is choice A. And I hope this question is now clear to all of you. So the last three questions that we did are real good questions. And in all the three questions, there were some process skills involved, where we translated the question, where we got rid of the powers, where we wrote difficult looking expressions into simple algebraic terms, simple numbers. Just for example, this question, I had four powers attached and we could just write this difficult looking expression into this simple an expression. So these process skills are really very much important for you to decrease the level of difficulty of questions when you get a difficult question. And how do you do that? We have an entire video list over YouTube. You could just search YouTube channel or you just type e-GMAT on our YouTube channel, e-GMAT process skills, and you get a video playlist of a lot of videos where you essentially land up with to learn what are the different process skills applied in the questions, and which would help you to understand questions better, which would help you to break down questions better, which would help you to decrease the complexity of questions better. Okay, I have a question. I have a question from Deepak. Does statement 2 tell A is odd? Yes. Now, from this statement, I can write that A to the power 4 is when divided by 200 gives a quotient of 1, right? Okay, this gives a quotient of 1 again. It doesn't give a remainder of 1, Deepak. Maybe in that you faltered a bit. So this gives me a quotient of 1. So what can I write? I can write this as 200k plus some remainder. I do not have any idea of this remainder. This definitely is an even part, but without knowing the R, we cannot say whether A is even or not, right? So again, a very important thing, yes, rightly pointed out, a very important thing. There would be a few people who can say that A can be even or odd from the statement as well. Right, so I hope all these four questions, all these 10 questions, the four warm up, the three in sprint one, and the three in sprint two are clear to all of you. And if you want to take a deep dive, we'll suggest that. But before that, let's learn the key takeaways. Again, we'll focus on the same things that you need to follow a proper approach, a unified approach to solve all questions. The tricks, the small shortcuts don't work in GMAT. The only things, if you want to score that Q50, Q51 level, then the only thing that you need to keep in your mind is to follow a methodical approach for solving all the questions. Now, if you use this approach and to solve questions, the process really become easy one by one. So the more questions you solve, it really becomes easy for you progressively, and it also becomes less stressful. So the less stress you have the more confidence, and with more confidence, you have a higher accuracy. So not only you follow a unified approach to solve questions, not only this process makes your journey easy, it also increases your accuracy. Everything is related. Once your accuracy is good, then going to that target score really doesn't become that difficult for you, right? So with that, let's first understand how would we do the entire process. So analyze these 10 questions again, and revise the concepts. Try to use the same concepts again in the questions that you got wrong, because this is a cyclic process, and that would increase the learning from 0 to 100. As I have already told you people that it's really very important to get inside the number properties chapter if you want to get a good score in GMAT. So this is a free resource for all of you. Just click on the link that just popped up in the chat box, and you can access a lot of content. So you get 25 hours of video content, you get access to 400 plus questions at the e-GMAT platform, and once you register, you also get access to 7 plus free webinars from our end. So that's really something that you should be looking out for, and it's only available till tomorrow. So go to that link and register. The next thing is, out of those 7 webinars I just talked about, we have one of those webinars tomorrow. So we have a GMAT Algebra webinar scheduled for tomorrow, where I would be discussing about difficult questions in inequalities and absolute values. And in just 2 hours, you would go from that 600 level or 500 level to the 700, 750 level in GMAT inequalities and absolute values. So do ensure that you attend this session as well. Right, with that, again, let me introduce you to the PSP plan of ours, the personalized study plan, where you can book a one-on-one call with one of our strategy experts and get to understand where you are going wrong if you are, and also ensure that you have a fully foolproof plan at your end, so that you invest the minimum time in your preparation but get the best results out. We have a very good team of experts here, and I've literally seen so many good reviews and so many people doing wonders through the help of this team. So it's really very, very, if you can get a hand of it, it would be really good for you. So go click on this link that just popped up, and it will really help you to decrease the time in your preparation and get to that best resources that you can expect or you can use to go to that target score of yours. So a question from Aris, who asks me, how much time would someone need to go from a 500 level to 700 level? Now this is completely subjective. What we would say is, take one step at a time, and we discuss about this plan, taking one step at a time, in our quant workshops as well. So if you want to attend that, it's available on our website. You can go and register for the workshop. It would be happening next Sunday. So in that workshop, we tell you how to essentially take one step at a time to first go from 500 to 550, then 600, 650, and then 700, then move on to the 720, 750 mark as well. But in that's a very subjective question, Aris, and I'm sorry that I won't be able to help you much. But yes, if you want to get a personalized plan for that, just contact us on at support@e-gmat.com. So let me write that out here. You can contact us at support@e-gmat.com to get to understand what should be the process, the optimum process that you should take to get to that level of yours from your current ability. So as next steps, what we would really recommend you people is go through the e-GMAT free trial, where you get a lot of content, free content, and that would really help you to understand number properties better, or even as a whole GMAT Quant, or the entire GMAT in a better format. So you get a lot of access, you get a lot of videos, you get a lot of questions in the free trial. What you need to do is just click on that link and go and register yourself. Also, I will be giving you a brain twister question. Now, this is I'll be talking about that question when I give you that. So let's keep that as of now. And do attend the webinar tomorrow. Today was on number properties. Tomorrow we have on algebra, and that would also help you a lot in understanding algebra better. I'm pretty much sure that after you attend the webinar, you can very easily relate yourself to algebra. So if you have a low confidence on algebra, that is definitely going to get up. The next thing is, you go to e-GMAT, and we have a very good tool called Scholaranium, and take the Scholaranium quiz. Now, the best part of Scholaranium is it gives you data, right? So you can essentially see what are the weak points, what are the weaker sections that I have. So that precise targeting really becomes very easy for you. You don't have to target the entire number properties if your problem lies on even odd. You just have to target even odd, and this tool right here is called Rhenium would help you to get to understand what are those weaker sections so that you can precisely target them, right? All right, so we come to the last question, and we won't be discussing this question, but this is a very nice question. And once you feel that you have made a good impact on even and odd at your end, then you can definitely try out this question. Now you can take a screenshot, or you can anytime come to this video and check this video out. So to answer this question, this is on even and odd property with a bit of Pythagorean triplet information that's required to solve this question. But one thing for this question, it's beyond the scope of GMAT. It's just to test whether you are at the 750 or 800 level or not. So if you feel that you are at that level, you can try this question, and I hope you would like this question a lot. So with that, I would be taking leave from you from our end, and I really thank you all for attending this session. And let me also take a moment to thank Shweta for helping me out to support this session with all the polls and all the information on the answering part of your or at your end. So thank you, Shweta, for that as well. And thanks all of you to attend for attending this session. I'm really looking forward that you would essentially register for the algebra webinar, and I'll see you tomorrow on that as well. Till then, keep up a very good health and take care of yourselves. Bye bye. I would request Shweta to please click on